Hello and welcome. Today we're looking at the reactions of aldehydes and ketones with nucleophiles. So for example, this structure here is a ketone because if you focus on this carbonyl, it has an alkyl group on this side and another alkyl group on the other side. So you have a carbonyl and then an alkyl group and an alkyl group, and that makes it a ketone. On this other example, you have a hydrogen on this side. So we have an alkyl group on this side and a hydrogen on the other side. So that makes that an aldehyde. So we see that both aldehydes and ketones have that carbonyl group. Now, if you introduce a nucleophile, which in this case I'll use a negatively charged nucleophile, the nucleophile will attack the carbonyl carbon in the ketone or also the carbonyl carbon in the aldehyde. And then the next step is that that double bond will move to the oxygen. So two electrons will flow to the oxygen. And that will result in what we call a tetrahedral intermediate, where now you have a negative charge on the oxygen and the nucleophile connected to that carbon if we focus on this first example. The next step will be reaction of this with water, or that process we actually call it quenching, where you basically introduce a hydrogen or a proton, a hydrogen ion, and then you end up with this as the product. You still have the nucleophile at that position, but now this has become an alcohol. So basically, the nucleophile adds to the carbonyl, and the carbonyl turns into an alcohol. So applying this, when water is used, either water under neutral environment, basic environment, or acidic environment, the end result is that you end up adding an OH nucleophile. So you connect an OH there, and then that carbonyl turns into an alcohol, and that becomes what we call a hydrate. When you use a base, that's sodium hydroxide, or water under basic environment, you still add an OH minus nucleophile. You end up with an OH at that position, and this turns into an alcohol. It gives us a hydrate, just like what we saw. When you use sodium cyanide or potassium cyanide or lithium cyanide, you end up with a cyanide negatively charged nucleophile. So you end up adding the nucleophile there, and that becomes an alcohol, and that's called a cyanohydrin. When you use a Grignard reagent, in this case methyl magnesium chloride, you end up adding the alkyl minus as the nucleophile. So you end up with the CH3 group added there, and that turns into an alcohol. In this case, we're using an aldehyde, and now we're using hydrogen cyanide, which still adds the CN as the nucleophile. So you end up adding the CN there, and that turns into alcohol. So both that and this are called cyanohydrin. This is called hemiacetal, and we say that this is also a hydrate. Thank you for your time. If you enjoyed this presentation, please like the video and also subscribe.